Hello student, this is your lecture number 6 for motion in one dimension, and in today's topic we are going to discuss about equation of motion, how to derive equation of motion. And remember that this is for uniformly accelerated bodies. So only for those bodies we apply these three equations. Let us see what are these three equations. First equation, as you know, is v equals to u plus at. In the previous video I told you v is the, according to sign convention, v is used for final velocity, u for initial velocity, a for acceleration, and t for time. This is your equation number 1. Equation number 2 is s equals to ut plus half at square, which can also be written as s changes to height, ut plus half g t square. When to use g? When a body undergoes free fall. Okay. Third one is v square is equals to u square plus 2as. Here also sometimes it becomes v square equals to u square plus 2ah. S is replaceable by h and a is replaceable by g. So these are the three equations which today we are going to derive graphically, and I am sure that after watching the full video you won't have any problem in derivation. So let's start with the derivation number 1, v equals to u plus 80. Before that, let us see what are the assumptions. As I already told you, final velocity v, initial u, acceleration a, and time t. For distance s. So let us see graphically. Let's make a graph here. Let a body initially with a velocity u started to travel and reached up to a final velocity v. This is your v and this is your u. Let us write it as u here, and this is your final velocity v. Look at the graph very carefully. Let here be point x and this is your point y. Take it as y. Let us take it as a and let us take it as b. You can take it in your own way. Let us mark this point also and write it as p. Okay, up till here you have to remember. After this, all depends on your how much you remember the mathematical formulas and how is your calculation. Okay, multiplication, addition, everything you have to use, and that is very simple. That is not very tough, complicated type. It's not complicated, it's very simple, but you should know what is the formula that we are going to use here. Some algebraic part we have to use. Okay, so let's start with our derivation. So for derivation number 1, that is equation is v equals to u plus at. See, what is acceleration? Acceleration is defined as change in velocity upon time. So where we are taking time, remember time is taken on this axis t, and where we take velocity, velocity is taken here. Okay, velocity is taken here. If you want to join here, you can write it as here like this. See, if there is any confusion, take it as capital V, otherwise you will mix it. So this is your final velocity. Either write it here or write it here, both are the same thing. You can write v here also. Okay, so change in velocity upon time. Now see, what is the change in velocity? Final velocity is v, initial velocity is u, so change will be v minus u, very simple, upon what is the time? Time is t. What is a? Acceleration, acceleration is a. Implies same thing as you did in the previous video. Take t there, so at is equal to v minus u. Very simple. Let us take it as equation number x1. I have taken it as equation number x1. Implies, if you want to take it like this, like this, we can take at equal to v minus u. Now what we have to do is we have to take this v alone. We need this v alone. Then what we have to do, whenever you need something alone, everything that is with that variable, you have to shift it to the other side. So what we have to shift to other side is u. The only thing with v is u there. So you will shift here. So at plus u is equals to v. Or I can write it as implies v is equals to u plus at. So this is your first equation, equation number 1. Okay, this is your equation of motion, first equation of motion. So in this way you have to derive equation number 1 with the help of graph. We have derived it graphically. Okay, so this was your equation number 1. Remember these terms, because these we are going to use in our derivation of second equation and this one also. Okay, at equal to v minus u and a equal to v minus u by t. Remember these equations also. Now let us go for the derivation of second equation. How to derive second equation, which was s equal to ut plus half at square. See, distance traveled according to this graph is equal to area of. Now see what is the structure that we are going to get. If I want to take out the area, what is the enclosed line? This line will enclose something, and you are getting something like this. If you see very carefully, if you take this part, you are getting something like this. What is this? This is a trapezium. In mathematics you would have seen this is the structure for trapezium. It means for calculating distance I need area of trapezium. And what is the name of trapezium? Y A B X. And if you want to connect it here, you can write it as YABXY. Okay, so this is the trapezium that you are noticing there. So area of trapezium, what I will do, I won't take it here with direct formula. I can break this trapezium. See, this part I have taken it here, so I can make a line here. So what I am getting? I am getting a triangle. Here I am getting a rectangle. I hope it is very easy for you. This part that I am taking from here is triangle and this part is rectangle. So I can write area of trapezium as area of triangle plus area of rectangle. In this way also I can write. Okay, what is the area of triangle? Half base into height, and area of rectangle length into breadth. Step by step try to understand it. It is very easy. Half base into height, from the smaller classes you know that, and rectangle same way, length into breadth. Now 1 by 2 will be written as 1 by 2 into base. See the base of triangle. This is the base of triangle AP. So write it as AP. According to this, A and P into height. What is the height of triangle? This is the height of triangle. So what is this? BP. BP plus length of a rectangle. Now do not look into this portion. This is over now. Now we have to look from here, from rectangle. The base is this one. So what is this? Sorry, the length. So length is YX multiplied by what is the breadth? XP multiplied by XP. Now what you have to do is you have to substitute the value. See, half into, where is AP? AP is this one. AP is definitely equal to YX, and YX is equal to this T that we have taken time. This is the time. Okay, actually this is somewhat wrong. We have to write it up till here, T. Okay, so this YX is equal to T. It means AP is also equal to T. As I told you last time also in the video, I told you that if suppose A equal to 2 and B equal to 2, it means A is equal to B. In the same way, if AP is equal to YX and YX is equal to T, it means AP itself is equal to T. So instead of AP, what I can write is, I can write T here into. Now let us check where is BP. See, this part is BP. How can I take out BP? If I take from whole, from the whole, I deduct this part, XP. I'm writing it here. If I want BP, look at it very carefully. If I want only BP, what I can do is I can deduct PX from BX. Do not try to memorize it. Okay, if I want BP, what I will do, I will deduct PX, only this much. PX I will deduct from whole BX. So what is whole BX? Look here, BX is your V. Okay, BX is your V. How you get to know? I told you that either write V here or you can write V here also. If you're writing it here, what is this? This is the V. Your BX is equal to V. And what is your next part? PX. What is PX? PX is equal to AY. Alternatively, if you see, PX is equal to AY and this is equal to U, initial velocity. So what you're getting from here is, you are getting V minus U. Again, look at it. If you want to get BP, what you have to do is you have to deduct this part PX from BX. BX in itself is V and PX in itself is U. So what I will get? V minus U. Now next part plus, what is YX? Let us see where is YX. This is YX. YX is equal to T. Already we discussed YX is equal to T. into xp. Xp is equal to ya equals to u. This also we discussed. Okay, so what you're getting is half into t into what was v minus u. If you have made a note, check what was v minus u. V minus u was equal to 80. How? Because a was equal to v minus u by t, it means v minus u will be equal to 80. If you have made a note of it, turn your pages and see. V minus u will be equal to 80 plus ut. So overall what I'm getting is, I'm getting half a t into t square plus ut, or I can write it as implies s, because distance is written as s equals to ut plus half at square. This is your equation number 2. So equation number 2 also we have derived. The second law of is the second equation of motion also we have derived graphically. With the help of this graph we have derived. Okay, so I hope this point is clear to you. If you want to note it again, you can pause the video and you can make a note of it. Now we are moving on to the third derivation, that is your third equation, which is v square equal to u square plus 2as. Now what I'm going to do is, I'm going to continue from the same point. Area of a trapezium. What is the name of trapezium? YABXY. YABXY. And now let us go to the straight formula of trapezium is equal to half sum of parallel side into, see, these are the parallel sides, okay, into base. What is the base? Yx is the base there. Okay, so this is the formula for trapezium. Straight formula of trapezium, we are writing it here, is equal to half. Let us write sum of parallel side. Which are the parallel side? AY plus BX. AY plus BX. So let us write it here, AY plus BX into, what is Yx? Yx is equal to t. Yx is equal to t. Very simple. Now we have to make some arrangements here. See, half into, what is AY? AY is equal to u. BX is equal to v, half u plus v, into, if you want to take t, let us go back to same equation, acceleration equal to v minus u by t, or I can write t equal to v minus u by a. I can write it like this, that time is equal to v minus u by. Why I am doing like this, I will tell you, because I want to make some arrangements. So what I will do, I will take t as v minus u by a. So instead of t, from here I can write v minus u by a. This I can write. Okay, and here what we are what we have to write, distance. Distance is s, as you know, distance is s, implies s equals to half. Now see, v minus u and v plus u. U plus v can be written as v plus u. See, u plus v can be written as v plus u. Why we are writing it like this? Because the first variable here is v. So I have v plus u, and in multiplication with this is v minus u. Now I hope you know what is the condensed form of this. Okay, the condensed form of this is v square minus u square. A plus b, in the algebra you would have learned that formula, a plus b into a minus b equal to a square minus v square. So instead of this u plus v into v minus u, what I'm going to write is, I'm going to write v square minus u square, and in the denominator part already a is there. Already a is there. So let us shift all these denominator part to the LHS part, left hand side. Implies, let this 2 go here, let this a go here, and s was already there. 2 went to this side, a went to this side. 2as equals to, no, half is not there, is equal to v square minus u square. Now what I can do is, I can shift left hand side to RHS, right hand side, and RHS to left hand side. Implies v square minus u square equals to 2as. And this is your third equation of motion. This is your third equation of motion. It is very easy. Here you are watching that there is lot of confusion is there, x y y x a b c d, like that. But when you will frame in your own way, you will get the answer. What you have to remember is, first part is very simple. First part is very simple. I hope it is noted. If not noted, again pause the video and note it. Again, I'm going to tell you how to remember, in what way you have to remember this. See, first equation is very easy. For deriving first equation, you have to remember acceleration equal to change in velocity upon time. I hope none of the student will have any problem in first equation. For second equation, just remember that S is equal to area of trapezium, but break it into triangle and break it into rectangle. Only this much you have to remember. For second equation, that is the derivation of S equal to ut plus half gt square, break trapezium into triangle and rectangle. For third equation, that is v square minus u square equal to 2as. For that, straight write the formula of trapezium, and rest is your adjustment. How you adjust the variable. Okay, if you know in what way you have to derive something, it doesn't matter what type of diagram you are making, what type of letters you are using. Suppose in the book it's written ox and you are using ab, you know it doesn't matter. It has no matter. It doesn't matters what variable you are using there. Okay, so no need to go for that bookish language, but you have to remember that what is the way to derive the equation. So this video was all about derivation of three equations. Okay, and these three equations you are going to use to solve your numerical question which are based on this chapter. So I hope these three questions are okay to you and you can derive it very easily in your examination or wherever you are asked to derive it. So keep growing, keep studying. Thank you.